have 7 school days till Thanksgiving break, so let's talk about what's going to happen in the world of math class. Looking at your outline for this week, you have a 4-5 worksheet today, a 4-7 worksheet tomorrow. On Wednesday, I'm going to mix the two of them on Alex. Okay? We are not doing 4-6. Then on Thursday, it is a review of the whole chapter, and then on Friday is your test. Okay? Next week, we are going to do a transformation mini project, rotation, reflection, translation, dilation. If you are going to be gone, I will get it to you ahead of time. It will be due then. You'll get all of class period. I take 0 amount of your time. And we'll talk more about that next week. But you will have a project next week. Okay, so just kind of a layout of 7 days. What do I have to accomplish? My goal really is that when you leave here Tuesday at 3:10, that you take nothing with you for math class. That's my goal, because that's how much I want to take home over Thanksgiving. I'm being real. Okay? All right. Today, you're going to see some things that we've already actually talked about, and then how it connects to what we've been doing with linear equations. So we're going to bounce back to scatter plots, which we've already talked about. So a scatter plot shows the relationship between a set of data with 2 variables, graphed as ordered pairs on a coordinate plane. Scatter plots are used to investigate the relationship between 2 quantities. If you have a positive correlation, it has a positive slope. As x increases, y increases. It's positive. As you work your way to the right, the line is increasing. A negative correlation, as x increases, we always work our way to the right. As x increases, what's happening to y? It decreases. And then there's a possibility of no correlation, where Miss Hoff calls mass chaos. It's just everywhere. We've already actually talked about this part. Okay? Determine whether the graph shows positive, negative, or no correlation. If it's positive or negative, describe the meaning in the situation. What are your thoughts on that scatter plot? I would say it's a positive. Okay? So describe the meaning. What they're talking about is use your x and y labels here. As the number of hours increases, what happens? The amount or dollars in wages also increases. I absolutely can. As the number of hours increases, the amount or the money in wages also increases. As x goes up, so does y. Scatter plots can show whether there's a trend in the set of data. When the data points all lie close to a line of best fit can model the trend. Now, it's a line of best fit. It doesn't mean it's exact. And we've kind of talked about this previously, like using a Sharpie, right? Hopefully it's touching most of the points. So in the process of this, you create the scatter plot. We draw a line that closely follows the trend. We write the equation using 2 points, and then we use our equation to predict data. Okay? Now, you guys have been writing equation using 2 points. Okay? You're going to plug this into point slope. You're going to plug this into point slope, but your final answer is in slope intercept. And we've talked about how you can manipulate to get y by itself. Now, because this is a line of best fit, it's not perfect. I'm going to tell you right now, round your slope to the nearest hundredth. Round your slope to the nearest hundredth. Hundredth is how many decimal points? 2. Put 2, if it's not a whole number, go 2 numbers after the decimal. So are decimals going to be acceptable today in Miss Hoff's world? Yes, because it's an approximation. All right? Flip it over. So here's a scatter plot they've created for us. The graph shows the average cost of a jet boat in the years after 2000. Using the data points 5, 25,108, and 10, 32,752, write an equation to represent the data. They always want this equation in slope-intercept form. Like I'm going to tell you on your Wednesday and on your Friday test, the computer will say y equals and you fill it in. I would not start in slope-intercept though. They gave us 2 points. What's the first thing I have to do? Y minus y1 equals m parenthesis. Very good. What's the first thing we're going to have to calculate? The slope. On your own, calculate the slope. Y on top. Y on top. I got 1,528.8. Yes? Okay. Now, there was only a 0.8, so I don't have anything to have to round here. Does it matter which point we use for point slope? No. Which one do you want to use? Okay. So our equation would look like y minus 25,108 equals, very good, 1,528.8 times x minus 5. Now what do I do? Distribute. Y minus 25,108 equals 1,528.8x minus 7,644. Is that correct? Yes? No? Yeah? Then what's my next step? Add 25,108. Y equals 1,528.8x plus 17,464. Yes? Easy way to check if you're way far off. You just found your y-intercept, correct? Y equals mx plus b. Is this approximately what your graph shows as a y-intercept? Well, 10,000, 15,000, between 15 and 20. Is your y-intercept between 15 and 20? Yes. Okay. Now, use the equation to predict the cost of a jet boat in 2005 and 2025. Let's just go 2025. How do I predict based off of this equation? Plug in what? 25? Why 20? Why not 2025? Very good. Reading your graph, it says years since 2000. So that would mean that x is 25 if we do 2025. So y equals 1,528.8 times 25 plus 17,464. Don't shout numbers at me because I'll never keep track of it. 1,528.8 times 25. Whoops. That's crazy. It's a whole number, isn't it? 55,684. Is that what you guys got? $55,684. It'd be interesting how accurate that is. I don't own a boat, but I've been told that boats are very, very hard to come by and are very, very expensive right now. So I'm going to guess this isn't, the trend did not follow this. Okay. So I'm going to tell you right now, if you want to say the difficult part is you're not going to deal with nice numbers. You're going to deal with, in this case, really large numbers, but possibly decimals too. Okay. The data shows the amount of milk that a baby goat needs by its weight. Use the data points 10, 20 and 50, 80, which are contained in the line of fit, to write an equation of the line in slope-intercept form. They give you the 2 points on your own. Find me this equation, and then I'm going to show you my answer here in just a minute. On your own, write your equation in slope-intercept form. Geez, this one's way nicer than the last one. Yeah. Make sure you put y over x. Y over x. Absolutely have yourself a decimal in this. Absolutely have yourself a decimal in this. Most of you are being really kind and you're leaving your number as a fraction. You do not have to. I got y equals 1.5x plus 5. Yes?
I got that.
Oh, you didn't have the negative. Yep, you didn't have the negative. You could, but we're going to end up using it down here, and you're going to plug in 17. So it's like the one time I let you actually use a fraction, or use a decimal.
What if you did like 80?
Same thing. You'll get the same thing. Yep. If you go 80 minus 20 and 50 minus 10, and you plug in 50 and 80, you'll get the same thing. Okay. Use the equation from part A to predict the amount of milk needed for a 17-pound goat and a 55-pound goat. Which one do you want to do? 17 pounds, which is your x. So y equals 1.5 times 17 plus 5. How much milk will that goat need? 30.5 ounces. Yes, it does.
The baby goat might explode.
Oh, it's up here.
Ounces. That's a lot of gallons. Okay, so I will be honest with you. I was really nice as you get started on this to be able to set you up with, I'll come back to this in just a minute. I tell you, like on number 1, what points to use. And on number 3, what points to use. Okay? So it should set you up pretty nice. Did I forget? My normal response is 972. 13, I think. Okay. What?
I said that.
972. Whenever